matrix is a rectangular array of numbers following certain rules, right? So it's a rectangular array of numbers. These horizontal lines are called as, yes, please participate. I want students to discuss now, because these are some topics that you've already learned. It is not difficult for you. Yes, anybody wants to share? What are these horizontal rows in a matrix, horizontal lines in a matrix called? Rows. All right. Okay, these are called as rows. All right. And what are these vertical lines called?
Columns, sir.
Columns. So these are called as columns. So this is column 1, column 2, column 3, column 4. So this matrix is of order 2 by 4 or 2 cross 4. 2 stands for rows and 4 for columns. So a matrix, so general notation of a matrix is we write Aij m cross n. All right. M is the number of rows. So I stand for the number of rows. So I will vary from 1, 2 up to m, and j will vary from 1 to n. So this is a matrix of order m by n or m cross n. Okay, so this is the general notation of the matrix. So when we expand this, this is like A11, A12, A13, A1, N, A21, A22, A23, A2N, M1, AM2, AM3, AMN. So this is a matrix where in Aij, I represents notation for the row and J represents the notation for the column. So you see here in this row, all the elements have the first subscript as 1, meaning that it is row 1. In the second row, the first of the 2 subscripts Ij, so I represents the row. So all the elements have the first subscript as 2, so on, and the last row has all the first subscripts of the elements as m. Okay, so these are m rows and then n columns. So column, you see the second subscript, this represents column 1. The second subscript here for column 2 is 2. The second subscript for column 3 is 3, and for the last column, the second subscript is n. Okay, it's m and n. So Aij, I and j are the 2 subscripts for this notation. So that is a matrix. Now there is a classification of matrix based on, there are 2 classifications actually. types of matrices, I say now based on its structure. Based on the structure of the matrix and the content of the elements, you have a certain type. And there is types of matrices based on properties. Now we'll come to that one by one. The first one is a row matrix. What is a row matrix? What is a row matrix? Anybody? Please share. Please feel free. Don't feel shy. You know the answers. What do you mean by a row matrix? You can, if you are shy to answer, you chat.
There are only rows and no columns are present in the matrices.
Yes, that means there is only one row. Row matrix means there is only one row. Okay, one row. So you have A, 1J. The order of the matrix will be 1 cross n. This is a row matrix. Okay. Example, you can say A is a matrix which has 1, 5, 11. This is a row, one row and 3 columns, but it is called as a row matrix. Second is column matrix. What is a column matrix? Again, answer. If you can answer row matrix, then what is column matrix?
It has only and no rows are present in.
Yeah. So it has only one column. So it is m cross 1. It has only one column. All right. So this is a column matrix. Example of column matrix. We deal with lot of column matrix in engineering, especially we solve simultaneous equations. We deal with column matrices. The variables, the variable matrix usually is a column matrix. Okay. Then row matrix, column matrix, then we have a rectangular matrix. The notation, see the notation, the way I'm writing. A is Aij, where, oh, okay, Aij order m by n, where m is not equal to n. The number of rows is not equal to number of columns. That is a rectangular matrix. In engineering problem solving and numerical methods, we sometimes have to deal with rectangular matrices. So let us say 2, 4, 6, 8 and 1, 5, 9, 13. This is a rectangular matrix. 2 rows, 4 columns, or 1, 0, 0, 1, 2, 1, 1, 2. These are 4 rows and 2 columns. It can be 3 by 4 or 4 by 3. So many combinations are possible. This is a rectangular matrix. The most important of all matrices is square matrix. And our notation for square matrix is m is equal to n. The number of rows is equal to the number of columns. The number of rows is equal to the number of columns. So this is a square matrix. So there's a square matrix of third order. Okay, order for square matrix, we just say order 3 or order n, means it is n by n matrix. It is understood when you say square matrix of order 3, it is 3 by 3 matrix. Okay, next, diagonal matrix. What's a diagonal matrix? Diagonal matrix is a square matrix, by the way. I will write it as n by n. Diagonal matrix is a square matrix. Okay, it is a square matrix where Aij is not equal to 0, or I would write like this, is not equal to 0 for I not equal to j, sorry, for I equal to j, and it is equal to 0 for I not equal to j. That means, see here, diagonal matrix, the diagonal elements will always be A11, A22, A33, so on. The diagonal matrix will be of this form. So when you write this, A11, A12, A13, A21, A22, A23, A31, A32, A33. The diagonal matrix is these are the diagonal elements. This is called as the principal diagonal. There are two diagonals, but this diagonal is called as the principal diagonal, and this is of importance, not the other diagonal. So your principal diagonal terms will not be equal to 0. At least not all of them will be equal to 0. So you have 2, 1, 2, and rest of the elements will be 0. So this is a diagonal matrix. So diagonal elements, principal diagonal elements are not 0. So Aij is not equal to 0 for I equal to j, and Aij is equal to 0 for I not equal to j. So these entities will be 0. So, okay, the lower triangular elements and the upper triangular elements here, these will be 0. That's a diagonal matrix. Then scalar matrix. This is diagonal matrix with scalar matrix.
So one question here.
Yes.
So you're considering the diagonal means the one diagonals, and we can see like we have two diagonals.
Yes.
If we try to plot, so why we are not taking the other one?
Because actually in our solution of linear equations, these principal diagonal terms will be the most critical. Okay, just let us go back to this equation here. See, we have converted this linear equation in the matrix form. Okay, So this is these are the diagonal elements A1, B2, C3. These are the diagonal elements. Now these play a very prominent role in your solution of equations. So generally what we do is like this: when you try to solve an equation, what do? We try to keep this term as it is and make the coefficients of y and z 0, so that you will find x. Then for the second equation, we try to adjust in such a way that other than this term, we make the other elements 0. Other two coefficients zeros. This is Gauss-Jordan method that we do. Actually, we do by hand calculation the same thing. Gauss-Jordan method is the matrix approach. So the principal diagonal elements play a very prominent role, not the other secondary diagonal elements. Okay, in solution of linear equations. So they are of very special significance compared to the other diagonal. So other diagonal, when they multiply, you can see, you can relate A1 straight away to x, B1 to y, and C3 to z. If these other terms, other elements are made 0, directly you will get this. So the whole idea of Gauss-Jordan method is you convert this matrix in such a way that you get here 1 1 1 0 0 0 0 0 0 and multiply with x, y, z, and you will get the solution here. Whatever is the solution, that means x is equal to a, y equal to b, z equal to c. Did you understand?
Okay.
Because the way we describe or way we define the matrix multiplication, that makes this principal diagonal terms to be prominent. It's a good question, fundamental question. Now, scalar matrix. So scalar matrix is it's a diagonal matrix where, tell me, what is a scalar matrix? Does anybody know? It's a diagonal matrix.
Diagonal elements equal to 1.
Very good. So off diagonal elements are 0 and the principal diagonal elements are 1. There's a scalar matrix. This is in fact, for a scalar matrix, there's a difference between a unit matrix and a scalar matrix. For scalar matrix, it will be equal to some constant k. All right. For example, 3 3 3, it's a scalar matrix. Why is it called a scalar? Why is it called a scalar? You see this. Suppose you multiply this with the column matrix. What we get is 3x, 3y, 3z. Upon multiplication, it is 3 times. It is as if you multiply this column matrix with a constant, a scalar real number. That is why it is called as a scalar matrix. Off diagonal elements is a constant. Now, unit matrix or identity matrix is a scalar matrix with the value of k as 1. So we know this. This is from high school. We have studied this, that unit matrix Unit matrix are matrices with diagonal elements 1 and off diagonal elements 0. Because you multiply this with any of the matrix, you will get the matrix itself. Just like in real numbers, you multiply 1 with any number, you get the number itself. Like that, in matrices, you multiply the unit matrix with any of the other matrix. Of course, they have to be conformal, that we'll discuss for matrix multiplication. So that's why this is called as the unit matrix. All right. This is unit matrix or identity matrix. Then we have null matrix. This is easy to understand. It need not be a square matrix. All elements are zeros. It need not be a square matrix. It can also be a square matrix, but it need not be a square matrix. So this is null matrix. All right. Then what next? Then you have, yeah, this is in matrix algebra. These two are extremely important matrices. Upper triangular matrix and lower triangular matrix. Does anybody know what these two matrices are? What is a upper triangular matrix? So in the upper triangular matrix, what happens is the elements below the principal diagonal are zeros. Okay, elements below the diagonal. When we say diagonal, it is the principal diagonal only. So basically, Aij is 0 whenever I is greater than j. Whenever I is greater than j, it will be 0. So here you see A11, A12, A13, A21, A22, A23, A31, A32, A33. I is greater than j. So I is greater than j in these cases. 21, 31, 32. So these elements are zeros. So you get a matrix like this. This type of matrix is called as an upper triangular matrix. Why? You see here the elements that are not zero form a triangle on the upper side of the matrix. So this is called as the upper triangular matrix. All right. This is very, very useful in Gauss elimination method of solving simultaneous equations. Lower triangular matrix. This is not so much used as the upper triangular matrix. If we can define upper triangular matrix, lower triangular matrix is easy. What is it? How will you define?
Above the diagonal are
Yes, elements above the diagonal are 0. Good.
elements above the diagonal.
Yes. So we write like this: Aij is equal to 0 for all or for every I less than j. All right. So elements above the diagonal, the principal diagonal, are 0. Elements above the principal diagonal are 0. This is the upper triangular matrix. So again, the same here. I will repeat this. So now I less than j happens for these elements. I is the first subscript, j is the second subscript. I is less than j for these. So
Sir, I think the 0 should be above.
pardon? Yeah. So here these should be 0 and so elements above the diagonal are 0, whereas others are not. So now when you see the elements below the diagonal and below the diagonal, they form a triangle. Of course, one important thing about lower triangular matrix and upper triangular matrix is one of the elements or two of the elements can be zeros. It is not that they need not be. But elements below the principal diagonal must be 0, all of them. So this also an upper triangular matrix here. Just because it is 0 here, that is not that it is not an upper triangular matrix. Similarly here you can have a 0. However, elements above the upper diagonal, the principal diagonal must be 0. Okay, so that's the idea.